Hi, this is Alan Begg from MacMaths, and welcome to today's lesson. The topic of this subject is going to be algebra. This is going to be an introductory lesson. Before we go on to algebra, we'll have a look at number machines, sometimes called function machines. Number or function machines are a basic form of algebra. Let's have a look at some examples. What's the missing number in this number machine? 5 plus what equals 10? It's 5 plus 5. The missing number is 5. 5 plus 5 equals 10. What's the missing number in this number machine? 15 minus 8 equals what? 15 minus 8 equals 7. What's the missing number in this number machine? Blank times 9 equals 45. It's 5. 5 times 9 equals 45. What's the missing number in this number machine? 60 divided by 12 equals what? It's 5. 60 divided by 12 equals 5. And this last example for now of number machines, 20 plus 10 plus 30 equals what? It's 60. 20 plus 10 plus 30 equals 60. These examples of number machines are basic forms of algebra. The next step, when we're talking specifically about algebra, is to replace numbers by letters. What is algebra? This would be a textbook answer. Algebra is the study of mathematical symbols and the rules for manipulating these symbols in formulas. Algebra is the study of mathematical symbols and the rules for manipulating these symbols in formula. An easier, simpler answer to remember is, in algebra, we substitute numbers for letters. In algebra, we substitute numbers for letters. This is the formula that we're going to look at. X plus y equals z. In this formula, z is what is called the subject. X plus Y equals Z. Z is what's called the subject. In this formula, X plus Y equals Z, X and Y are called variables. In this formula, the X and the Y values are called variables. This would be the standard format that you would write a formula, like what we saw in the number machines. 5 plus 10 equals 15. If you were to convert that to algebra formula, it would be X plus Y equals Z. In algebra, we substitute numbers for letters. Instead of a formula containing entirely numbers, algebra formula would consist of a mixture of letters and possibly numbers also. Let's look again at our formula X plus Y equals Z. Here are the values of these letters. See if that's true. X plus Y equals Z. Now let's substitute in the values of these letters into our formula using these values. 5 is X, plus Y is 10, equals Z, which is 15. 5 plus 10 equals 15. That's correct. A plus B equals C. So the formula that we've looked at so far have involved X, Y and Z. There's no rule about having to use X, Y and Z. You can use any specific letters that you like. So here's the exact same values, 5, 10 and 15. Put them into A plus B equals C instead of X plus Y equals Z, and it still works out the exact same. 5 plus 10 equals 15. So you can use any letters that you like. Most textbooks tend to use X, Y and Z, but there's no reason why you can't use whatever letters you like. Here's some different numbers. X equals 100, Y equals 2 and Z equals 102. X plus Y equals Z. Let's see if that's true for the numbers that we have here. Substitute X for 100, substitute Y for 2 and substitute Z for 102. 100 plus 2 equals 102, and that of course is correct. Now in this instance is where we start algebra for real. We don't know one of the values. X plus Y equals Z, but we don't know what Y equals. So the challenge here is to work out what Y equals. Put it into the number machine, but in algebraic form. X plus Y equals Z. Substitute in the values that we do know. 5 for X, Y we don't know, and 15 for Z. So what plus 5 equals 15? we need to work that out so that we know what y equals. 10. 5 plus 10 equals 15. So that means that y equals 10. Next example. X plus y equals z. X equals 315. Y, again, we're looking for the value of y, and z equals 400. Substitute the numbers in for the letters that we do know. Gives us 315 plus y, which we're trying to figure out, equals 400. So what number plus 315 equals 400? Think of it as 400 minus 315, and that equals 85. So in this specific example, y equals 85. X plus y equals z. 315 plus 85 equals 400. A plus B equals C. Exact same values again, just to reiterate that you don't have to use X, Y and Z. This exact same values work for A, B and C. Exact same answer as the previous time. 315 plus 85 equals 400. B equals 85. Let's do some basic algebraic questions. This is the formula we're going to use. A minus B equals C. A is 20, B we don't know, and C is 17. Substitute the numbers into this formula that we do know. We get A is 20, B we don't know, and C is 17. 20 minus B equals 17. So 20 minus what equals 17? It's 3. 20 minus 3 equals 17. So that means that B equals 3. Next question. X multiplied by y equals z. X times y equals z. Here's the values we do know. X equals 5, y we're trying to find out, and z equals 45. Substitute the numbers in that we do know. 5 times y equals 45. So what number times 5 equals 45? Or you can think of, what is the result of 45 divided by 5? It's 9. 5 times 9 equals 45. So in this example here, y equals 9. Question 3. A divided by B equals C. Numbers that we do know. A equals 36. B is what we're trying to find out. And C equals 6. Fill in the numbers into this formula of the values that we do know. A equals 36, B we're trying to find out, and C equals 6. 36 divided by what number equals 6? Or think of it another way of 6 multiplied by what number equals 36? It's 6. 36 divided by 6 equals 6. Next question. E divided by F equals G. Fill in the numbers that we do know from this information supplied. It gives us 200, which is E, divided by F, which we're trying to find out, equals G, 25. 200 divided by what number equals 25? Or think of it as 25 multiplied by what number gives 200? It's 8. 200 divided by 8 equals 25. Next question. A minus B equals C. In this example, we don't know A. B equals 14 and C equals 40. Substitute the values in. A minus B, which is 14, equals C, which is 40. What number minus 14 equals 40? Or the other way to think of it is, what number is 40 plus 14? It's 54. 54 minus 14 equals 40. Next question. A minus B equals C. The exact same values as the previous example. Just to show you again, it doesn't matter what letters you choose. A minus 14 equals 40. Same result as question 5. 54 minus 14 equals 40. Question 7. A squared plus B equals C. So now we've got an example with powers. A squared plus B equals C. So it's not always just pluses and minuses of base numbers. Here's a number with a power. And that's what we're going to try and find out. B is 10 and C is 19. Let's put the numbers in that we already know. A squared plus 10 equals 19. So what number plus 10 equals 19? Or think of it as, what is the number 19 minus 10? That's going to be 9. 9 plus 10 equals 19. So what number squared equals 9? It's 3 squared. 3 squared equals 9. So A is going to be 3. 3 squared, which is 9, plus 10 equals 19. So the answer wasn't 9 because it's A squared. So we need to find the square root of 9, which is 3. 3 squared, 3 times 3 equals 9, plus 10 equals 19. Next question. A squared minus b equals c. Again, A is what we're trying to find out, b is 81, and c is 0. Put in the values that we do know. 81 is b and 0 is c. What number minus 81 equals 0? Well, to get 0, you've got to subtract 81. So 81 minus 81 equals 0. So what number squared is 81? Alternatively, what's the square root of 81? That's 9. So 9 squared, 9 times 9 is 81. 81 minus 81 is 0. So for this, a squared minus b equals c. For these numbers, a equals 9. This example, a squared plus b equals c. Here's our values that we do know. B equals 40, c equals 56. A squared plus 40 equals 56. What number plus 40 equals 56? Or think of it as 56 minus 40 gives what number? It's 16. 16 plus 40 equals 56. So a squared is going to be 16. So what number squared is 16? Or what is the square root of 16? The answer to that is 4. 4 squared, 4 times 4 equals 16. 16 plus 40 equals 56. And for this example here, a equals 4. Next question. A cubed minus b equals c. So a times a minus b equals c. A cubed. Here's the values we knew though, and here is our target. Again, to find out what a is. Put the values in. A cubed minus 27 equals 0. What number minus 27 equals 0? It's 27. So a cubed is equal to 27. So what number times itself and then times itself again, a times a times a, is 27. It's 3. 3 times 3 times 3 is 27. 3 times 3 is 9, times 3 again, 27. So in this example here, a equals 3. 3 cubed minus b equals 0. Next question. A plus 2b equals c. Now we've got 2 lots of b. A plus 2 lots of b equals c. A plus 2b equals c. Here's the values that we do know. B equals 25, C equals 100. Put them into our formula. A, which we're trying to find out, plus 2b, 2 times 25 equals 100. 2 times 25 is 50. So what number plus 50 equals 100? Or 100 minus 50 equals what number? It's 50. 50 plus 50 equals 100. So A equals 50. Last question. A divided by 3 plus 4b equals C. A divided by 3 plus 4 lots of b equals C. Here's the numbers that we do know. B equals 5, C equals 24, A is our target. Put it into the formula. A divided by 3 plus 4 lots of 5 equals 24. 4 lots of 5 is 20. A divided by 3 plus 4 equals 24. So what number divided by 3 plus 20 equals 24? It's 12. 12 divided by 3 is 4, plus 20 equals 4. A divided by 3 plus 4b equals C. 12 divided by 3 is 4, plus 4 times 5, which is 20. 4 plus 20 equals 24. How did you get on with those questions? I hope you found that basic introduction to algebra useful. If you did, then please like, share, and subscribe. Until the next time, this is Alan Begg from McMaths signing off. See ya.